right, so we are going to look at a practice problem using the ideas of wave intensity and power. And so if the intensity of an earthquake's P wave is detected 100 kilometers from the source of that earthquake, that intensity is detected at 1 times 10 to the 6th watts per meter squared. What is the intensity 400 kilometers away from the source? And what is the power of that earthquake, the power of that wave? All right, so for part A, what is the intensity 400 kilometers? So for part A, we are going to look at the information that we have. We know that the intensity at 100 kilometers is equal to 1.0 times 10 to the 6th watts per meter squared. We are interested at the intensity at 400 kilometers. So what is that equal to? Remember, our intensity equation tells us that the ratio of the intensities, I2 to I1, is equal to that reverse ratio, R1 squared over R2 squared. And so we have all the information we need. So I2, this is I2, this is equal to I1. All right, so if I solve for I2, I get R1 squared over R2 squared times I1. We don't actually have to convert our distances to meters because they're in a ratio form. So the unit, as long as those units are the same, we're okay. So I have 100 squared over 400 squared times 1.0 times 10 to the 6th. And I find that my intensity is 6.3 times 10 to the 4th watts per meters squared. So using that intensity ratio relationship, that looks at the intensity relative to the distance from the source, and get my intensity at 400 kilometers. Okay. Part B asks us, what is the power of the wave? So for part B, we want to remember that power was equal to that intensity, we'll solve for power, that intensity was the power through the unit area perpendicular. Remember our definition. If you haven't looked at that video, go back and look at the video where we introduce the idea of what intensity means. But mathematically, if I'm talking about moving out from a sphere, we have the power divided by 4 pi r squared. So we're going to use that relationship with our intensity. So I'm going to solve for P. When I solve for P, I end up with the intensity times 4 pi r squared is going to give me the power of that wave. So let's do that over here. The power equals the intensity times 4 pi r squared. Now, which r do I use? Well, turns out you can use either one. The power is the power of the wave, and we can actually use either one to solve for our power. We just want to make sure we're using the right radius. So I'm going to use the first one. I have 1.0 times 10 to the 6th, 4 pi. Now, in this case, we do want to make sure our radii are consistent with our units. If I am using units of watts per meter, I need to have my radii in meters. So I have 100 times 10 to the 3rd meters. And I can see I am just a bit out of my screen. So I'm just going to move this over for you. So we have 1.0 times 10 to the 6th times 4 pi times 100 times 10 to the 3rd. It was 100 kilometers squared, and that puts me where you need to see it. All right, so when we calculate that, we found the power of our wave to be 1.26 times 10 to the 17th watts. All right, and again, if you use 6.3 times 10 to the 4th and 400 times 10 to the 3rd for our distance, we'll see that the power is the same. All right, so just practicing using these ratios of intensity and how they're related to the distance squared and practicing with our power equation. Good job.